Hello, in this video we're going to look at how to make an MMO or an RPG inventory system inside Unreal Engine. We're going to do this using just blueprints, so no C++ code required here, but we are going to be using this free plugin called VA-REST. So VA-REST is just a free plugin inside Unreal Engine which helps us with API communications, so sending API calls to our server. So this is basically a continuation of the previous chapter where we've set up the server code. So basically now this is running in the background and we're going to connect the Unreal Engine to it. So as usual, all of the code, or rather like all of the blueprints required for this implementation are found on this blog post. So it goes through step by step how do you get this thing running and working. And what I'm going to do is I'm going to show you a quick demo of what it is that we're building so that you can see whether it's something that you want to do. So basically I created a fresh project. This is using UE 4.27, but this will be compatible with UE 5 as well. So we've got a little widget here representing our inventory, so it's going to be a 10 by 10 system. If I click on an item, we drop it, and here we are running around so it can tell us how many items there are. If I click spacebar, we pick it up. So all of this is done with communication to the server. So if I drop a couple of items, the other cool thing is that we do all of the reloading. So here we see 2 items. If we move far enough away, there's 0 items. If I run back in, it will load them up again and spawn those objects. So the other thing to mention, I suppose, is that it's stateless in a sense that the Unreal Engine itself doesn't keep information about this. So all of the state information is stored on our server, so it's stored inside MongoDB. So even if you were to shut down the server and restart it again, this data still persists, right? So that's the key thing here about making it MMO style. Okay, so if I close this, we can basically have a look at what it is that we're building. So what we have is the vast majority of the blueprints are inside this inventory folder. So we need to create a couple of widgets, some models for the data transfer. We'll create actors for the objects that are spawned on the map, and a couple of helpers. So this is to help with translations of JSON to our structures. So we'll have a look at the widget first. So I'm going to talk about it from a high level, just so that basically all of the steps are in the blog post, and if I was to describe them step by step, this will be like an hour-long video. I think it's better to just give the concept of what it is that we're doing. So inside the inventory widget, what we want to do is we want to call an API to get the inventory itself. So you can see this happening with the VA-REST plugin. So if I go over here, let's find the get inventory API call. So this is the API call that we're making. The body that we're creating is over here. Sorry. Oops. So basically, get inventory request requires no body, so it's just a get URL. We do need a couple of headers, which are over here, and the response is over here. So the response itself is quite complicated, and we want to refactor it out, and that's why we've created the helper methods, right? So the helper methods are just there to keep our blueprints a little bit cleaner. So this is what we have. We have a construct JSON request, so it's a get request, URL encoded parameters. And you can see the URL specified over here. As I just mentioned, we have to specify the headers. So we've got the content type, the accept, and the key one here is the character name. So at the moment it's just static. I've set it to character 1, but obviously as you log into your game, you can specify the character name, and you expect that to be unique, right? So you shouldn't have more than one character with the same name. Okay, so once you've got the data, there's another function to basically get the data from your VA-REST JSON. So it could be like get string field, get number field, get array field, or get object field. So what I'll do is I'll quickly show you like what does each one represent. So this is just basic JSON really, but if you have a string, you'd use the get string field, right, or set string field. If you have an array, you literally say the get array field. And anything that begins with these curly brackets, they're considered objects, so JSON objects. So for example, you could say get array field for character items, and it will return you an array of objects where each one is another JSON representation of an item. So that's what we're doing, and we're using some helper methods to convert this data. So basically the input is the JSON object, you'll see here, and the output, we're just basically trying to construct the structure that we can use inside our blueprints, so that it's basically easier to pass around blueprints and just use them. So that's what the helpers are for. In terms of I'll quickly just show you the models. So because they might seem complicated, but really all they are is just a mirror of the data that we have in our server. So for example, this is our item model, and you can see it has a string field for the item ID, item name, category, and it's got some slightly more complex structures like tags, which is a key value pair. So we can see here item ID string, item name string, value, and there's tags, for instance, which is an array of this tag structure. And if we find tag, it's just a name value pair, right? So it's just really mirroring the data that we have in our server. Okay, so let's go back to the inventory widget. So basically, we have an API to get the inventory from the server. Once we get it, we can construct our structures with it, so the character item structures. And then once that's done, we call this method to start populating the items inside the inventory. So you could, in theory, basically just take the items that you got and simply dump them inside the inventory, so basically wipe and replace them. But that's a little bit buggy, so what you actually want to do is find the delta between the two, right? So that's why we have, for instance, this map temp and the actual map. So what we do is, I'll show you the structures. So the key is going to be the location, the position inside the inventory where the item resides, I suppose, and then you actually have the character item. So basically for each one that you require to add, you basically create the inventory widget and you keep a reference of it inside this widget list. And for anything that you need to remove, you iterate through each one and you locate it inside your widget list, and then you simply remove it from parent. So this looks a little bit complicated. Again, it's described a little bit more inside the blog post. But to be honest, the blueprints kind of inflate this logic, because if you were to code it out in Java, C++, this wouldn't look so big. But that's the nature of doing this inside blueprints. But it works pretty well, as you can see. And if you have a look here, this timer is set to 0.5 seconds. That means we call our get inventory request every 0.5 seconds, which is far more than you need to, really. So I'd imagine that maybe you can run this every 10 seconds or something to reconsolidate the data inside your inventory. But in reality, what you should do is you should have a refresh for every action which can impact your inventory. So for example, drop item should call this event to get inventory event in order to refresh itself, right? So for example, equipping item, dropping item, moving item, it doesn't really matter. So all of these actions can just basically force refresh inside your inventory. So now we can have a quick look into our second widget, which is the inventory slot widget. This is a tiny widget, so you saw here that, you saw here that you have this inventory, and the key component in the design here is this grid panel. So the image does nothing really. I mean, I've just given it an extra shade so you can see it, but you're going to put a cool design here, essentially, right? You can go on Fiverr, ask someone to design you something really cool, and make a nice layout here. But the cool component is this grid panel, which is a uniform grid panel component. And why it's nice is that basically you have the size to content and some padding, and you can specify how you're going to be adding those components in. So if I go into here, where I add the item, so you create an inventory slot widget, add a child to uniform grid. What you can do is you can specify the location where you put it. So in our inventory example, it's a 2D matrix essentially, right? So we've got the X coordinate and the Y coordinate for the position for the item, and it works really well with a uniform grid because you can specify, where does it actually position itself. So that's what we're doing here. So we're using this uniform grid component. And it's basically, yeah, like if you say put it on row 3, column 2, that's where it's going to put it, right? So that's why it's really nice. And the actual widget for the inventory slot, this is just a tiny widget, 60 by 60 component. The main things, again, is that it has this item image field. So at the moment, we don't set it to anything. So as you receive the item, you can populate it with an image. And you've got the item button. So again, like with this item button, every time you click on the item, you can make a modal pop up, which, you know, you can have another menu to equip item, drop item, consume item, whatever you like. At the moment, we've just programmed it to drop the item when you click on it. So if we go onto the graph, the very first thing that we do when we construct this widget, we basically set the image on the background. So I've added a new field here, so it'll be just basically anywhere. So item config field, and we specify this icon and a mesh. To be honest, I'm not using the mesh right now, simply because it didn't actually support the actor loading from file, but the icon did support it. So I don't think that this is necessarily going to be the best way to do it. I was playing around with this, and it's one of the ways to do it. But the second way would be essentially to have a mapper inside your helper, which is what I've done with actors. So if I go to helpers, we've got this item actor resolver field. So you can do something very similar for your image for the icon, right? Like inside your inventory. So what we have is like a map to actor, and you can have map to icon. And basically this is going to be a map of item ID. So here you'll have something like item ID, and you map it to a particular file or image, or, you know, whatever you like, really, right? So you can have another consolidator or another mapper from your item ID to whatever it is that you're pointing towards. So that's one way of doing it. So we basically load it directly from the response, but you can have another function to evaluate the item to draw. And as you can see here, we're just basically setting the brush from texture. And if you look at the component here, that's what it is. It's under appearance brush, and you can specify the image. So that's what this function is doing. And then basically when we click the button, what we want to do is we want to drop the item. So again, this is just another post request. So you construct the JSON request using the VA REST subsystem. You set the headers. You formulate the drop request. And the drop request, I'll quickly show you over here. You need this data, right? So you need to specify the character name, the location of the item inside your inventory. This is the XY coordinate representing your inventory slot, and the location where you want to drop the item, right? So we specify the map, which we're not really using, we're just keeping that as static, but the X, Y, and Z coordinates for it as well. So the X, Y, and Z coordinates, we get it via the player location. So we get the player, we get the location, we get the vector, and then we specify the location. And we get the character name and the item location via the constructor that we set it out of the inventory process. And we formulate this request. So this is one of our helper functions, right? Which simply like takes the structure, and then it goes field by field, setting the JSON objects, right? And these are nested objects, so you can see every time you generate make JSON, it just means that you make another object inside the JSON where it has the curly brackets. And then you can set the object later on. So go around here, set object field. We have the core JSON, and you assign the location 2D, for instance, that you've constructed here. So that's simply how sort of JSON works. Have a look at it. It's very useful in any API communications. So let's go back to here. Okay, so we formulated our JSON request. We just do some debugging here. We set that request up, and we apply the URL, and we're basically done. So basically, for instance, at this point, you can actually tell the inventory widget to go and refresh itself. So I haven't done that, but you know, that's what you'd normally do in order to have less refresh calls inside your inventory widget. And that's basically it for the inventory slot. So let's go back. That actually covers all of the widgets, right? We just have the inventory widget. So potentially the next thing that we can look at is the blueprint for the game mode. So what I've done is, inside the game mode is where I populate the nearby items. So you could put this in your character controller, maybe elsewhere as well. I decided to put it into the game mode simply because perhaps I'll want other blueprints to be accessing this. So if you put it into the game mode, it'll be accessible in many places. You can evaluate the logic elsewhere. Maybe you want to populate the variable here. It's up to you, right? It doesn't matter too much. So what this does is, when you start the game, we're going to start looking for the nearby items. So again, in a very similar fashion, every 0.5 seconds, we refresh our screen essentially, right? We check what nearby items do we have, and let's populate them on the screen. So in order to do that, it's another get request, and we're getting the dropped items. So if I go here, get nearby items, so these are the dropped items, and what we need to specify is this URL encoded information for the map, X, Y, and Z coordinates. So they're over here as well. So if we look at our request, URL encoded content type, it's a get request, and what we do is this location to string. So basically we need to get the player location. So we basically say, let me get nearby items to the player. So that's why we get this player's location. And instead of JSON, we create a string out of this data. So if we look inside this function, you basically take an input of a location, and then you do some concatenations, like however you say that, to produce this string over here, right? So you've got this question mark, then you've got the map, X, Y, and Z. So that's what you do here. You basically take some bits of information and you append them together to generate that string, and you append it to the address that you want to send a request to. So in our case, we're running on localhost, so that's the API. And you apply the URL, which basically starts the call. When it returns, you basically get the object for the dropped item list, and you start populating it internally. So in a similar fashion, this is relatively complicated, but it's doing something pretty similar. You've got this temporary map of information where the key is going to be the ID for the dropped item. It's a unique identifier. And then you've got the dropped item structure. So what you do is you want to find out the delta between the items that you've received now and what you've had in the past. Anything new you want to add, anything that's you don't have anymore but you had it in the previous state, you want to remove. So that's what you basically do. You have a couple of for loops for each one. You basically you can kind of see what happens. Again, the blog post covers it. I don't want to make it more confusing by describing something potentially wrong or erroneously. Okay, so basically, when you've got the dropped item and you want to add it to the map, what you do is you need to get the location for where you need to place the object. So if okay, we've got an item. So part of here, you've got the location for where the item is dropped, and that's what you get out here. So when you spawn the actor, you need to basically say, what actor am I spawning and where is it going to go? So this function here is what we looked at earlier. So we've got this item actor resolver, so where we've got the item ID to the item actor that we're resolving. Now I'm using free assets in order to draw these items. So if I go into content, I've added one set of assets called craft resources. So that's why you're not going to see my inventory icons matching the actual meshes, right? Because I'm using resources icons for the icons in the inventory, and then for the actual meshes, I downloaded the Infinity blade weapons. So there's a couple of weapons here as well. So I'll show you some examples. So for example, we've got this item here, which is like a hammer. So I've taken this hammer and then I've created a actor class, right? So on this actor class, all I needed to do is simply add in a skeletal mesh with specifying the mesh here. I'll demonstrate how you can do that from scratch. And obviously, you don't have to do it in the same way. You can basically change things around as per your requirements. But this is one way of achieving this, I suppose. So I go back to here. So that's how we resolve the actor. And again, I'll give a quick demonstration of how you can add in a new actor. And you add it to the spawned items on map list. So, and then when you need to remove the items, you use this spawned items on map to remove those objects. So if I click on spawn items on map, so again, the variable is a map to the actor object, and the string here is the identifier for the object, which basically means if, for example, you pick it up or another player picks up the item, and it's no longer part of the get nearby items request, you need to remove that actor. So you need to keep the reference of it somewhere so that you can go and remove it, basically. So that's what this piece does. And at the very end, you basically replace the two variables. So the nearby items is equals to the temp that you've assigned at the very beginning over there. Okay, so that's the top-down game mode, which populates the nearby items. So potentially the last thing that we want to look at is the top-down character blueprint. So the first thing that we'll show here is basically when I click the I button, I'm going to set the visibility for my inventory widget. So as you saw, when I click I, my inventory appears and disappears. And I've also created a little function here called get nearest item ID. So what this is doing is, this is again just refactoring that bit of code out, but as we saw earlier, we've assigned the nearby items inside our game mode. So we load in our game mode and we get the nearby items. We check how many items are there, and if it's got at least one item, we basically return found. So this is the return statement for this function. And again, if it's found, you want to return the zeroth element from the nearby items. Okay, so that's what this function does. And we basically use it inside our functionality here. So I created a new graph for this just to keep the other one a bit neater. And yeah, you basically use, when you click spacebar, you get the nearest item ID, so the function we saw earlier. And if there is at least one item present, then we basically try and call the pickup item request. So this is another API call. And very similar way, we set all of the headers and we configure the JSON for picking up the items. So if I look at the pickup item request, the body is very simple here. It's just the dropped item ID. So this is a unique identifier for the item. So we don't really need anything else in order to process it. Again, the character is defined by the header. So that's how we know when we say pick up this item, that's how we link it to the character. And when we apply the URL, we don't actually need to do anything else, right? Because the map consolidates itself, it refreshes every 0.5 seconds. The inventory does the same thing, but likewise, you could basically say get the widget component, get the inventory, so get widget by class, and then you basically tell it to refresh itself, right? And that is basically it. So what I'll do perhaps is I'll show you how you can add in your own item. So let's have a look. I'll go into the craft resources. I'll pick out a icon to use for our new item. So it, not really sure, like the icons don't really match any of the meshes that we have, but let's go with this one. So there's some item here. We'll copy the file path. We're going to create a new item. So we'll give it an ID of 2. I don't know. We'll call it pickaxe or something, right? 15 damage. And this part is important. So we want to get the PNG for this. So that's what the icon will be representing. So I'll click send here. So if I get a response, that means it was successful. Okay. And now what I'll do is I'll find a mesh to represent that item, so that when we drop the item, we use a specific mesh. So again, I'm not 100% sure what mesh to use. We'll go with an axe, right? Like a random axe. Let's just do with this one. So blade, fisher blade. So if I go into So we'll create a new actor class, basic pickaxe. So what you want to do is you want to have an actor component for your items. So it's called fisher blade, so there it is. And what I'm going to do is I'm just going to rotate it. Okay, so now we've got ourselves a new actor, and we just wanted to add it to the list of the resolver. Okay, so here we'll create a new item, 2. And we called it basic pickaxe. Okay, and that should do it, right? So now what you've done is you've created a new item in the server. So that's what we did here. We basically specified what icon to use, and we do this using this full path. To be honest, I think you can just create another resolver as we did for the actor mesh. Then we've created a new actor to represent the dropped item, and then we've added that actor into this resolver here. So if I click run now, so there's my other 2 items that I dropped earlier. If I go into here, so there's a function inside our server to spawn an item. So for example, if you kill a monster or whatever, you can basically say spawn this item at a particular location, right? This could be a hook on some other event. So if I click spawn an item with an item ID of 2 and spawn it at this location, it basically generates the item. It gives me the ID for the item, and there it is. So there's my new spawned item. So I can try and basically, I'll pick it up first. So there's my pickaxe, right? And you can see it sort of happening again. There it is, right? And that's our basic inventory system connected with a server. Okay, maybe I went through it fairly fast. I'm not sure. If you've got any questions, pop them into the comments. Also, we've created a Discord channel. It's fairly new, so feel free to join and you can ask some questions there. But yeah, best of luck and see you next time. Thanks.